So to make a reflection, I'm going to show you in Geometry Sketchpad. I don't know if you ever clicked on a line or a point and it made that double square. That's showing that that's going to be the line that I'm going to be reflecting over. So this shape over here and all of its pieces, I'm going to go to transform and reflect, and it will map over here. There's a couple of things that we can tell about this. So a couple of things that you can notice from this. If we were to connect A and A prime with a segment and D prime with a segment, you'll notice that all these segments are different lengths. But if we look at all these segments as a whole, and I'll kind of highlight them, that little one here is kind of caught up in the others. If you look at these three segments as a whole, they're all parallel. And that's what makes it a reflection. So if I go back, how I did this creation or this reflection was, if A is one space away from the line of which remember I double clicked this, then it's going to be one space perfectly on the opposite side. But if you notice, when I connect A and A prime with the segment, and I look at that line of reflection that I double clicked, they're hitting at a 90-degree angle. And that kind of happens with each one that I've built. D is 3 spaces away from the left of the line of reflection that I have going along the y-axis here. So D prime ends up 3 spaces to the right. And if I connect D and D prime, and I look at that line of reflection, again, perpendicular, that they're hitting at. That's how I know exactly where to put these points. Of course, Geometry Sketchpad does it for you, but it will be a little bit different when we go to do this. We look at those pink lines right there, they're hitting at a 90-degree angle. It'll be a little different when we try to do this on an angle. So what I did was I graphed this line over here. Y equals, looks like it's going -1 for a slope, and it started at 3. So we do have to remember how we graph lines as well. That endpoint is our B value. It starts at B, and we go down 1 over 1, down 1 over 1, down 1 over 1. We do want to use the entire graph. And the whole idea for this was to actually see what happens if we flip this. And that's basically what I'm doing, reflecting this over this diagonal line. Now notice if I double click it, I get that double square. So that's what it's going to flip over. And I'm going to select all these points again. I don't want anything extra, so I'm going to take off this guy, take off this guy, and I'm going to go up to, if you want to duplicate this, go up to transform, reflect. And I end up with it up here. And I took a minute to put the points on. We call that D prime. That's where D flipped over and landed here. We call this A prime. It flipped over and landed over here. C prime because it flipped over the line and landed over there. And B is kind of far away and it flipped over and landed over here. But let's look through each one of these for a second. If I construct all these segments here, so let's take a peek at those. Remember what I was doing before? I was connecting them before and we were noticing something. If I do highlight all of these segments connecting C and C prime, D and D prime, A and A prime, and B and B prime, you'll notice all 4 of these pink segments here are all going at that same slope. So these are all parallel. That's that vocab word to describe these ones. And if I take all those off and we look at one at a time, and I just look at A to A prime, notice the connection between A to A prime and the line of reflection that I have going down the middle of this. This slope is now up 1 over 1. This one is down 1 over 1. These are perpendicular because they hit at their slopes are negative reciprocal, and they hit at a 90-degree angle. And if I look at that for all of them, oopsies. If I look at it for D to D prime, the same thing holds true. So in geometry, it's not just estimating where it flips over to, it's giving the actual points of where it flips over to. And this is the easiest way that I can do this based on whether we're doing this horizontally, vertically, or if we're going to do this diagonally. If I look at something like B and B prime, these are very difficult to kind of figure out. Because they're so far apart. But I do know that whatever this angle is over, or whatever this slope is that this is going down at, then B to B prime has to be the negative reciprocal slope. So that's the easiest way to get there. It's not easy to count the spaces because we're going diagonal. But I guess we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can count 12 diagonal spaces to get from one to the other. So then this should be 1, 2, 3, 4, 5, 6 right there. So another way of thinking about it is right here where it crosses is the middle point between B and B prime as well, with an equal number of length on the left side and the right side.